Hey everyone, and welcome back to Talk Tensors. Today we are going to unpack this paper called Learning Beyond the Surface. How far can continual pre-training with LoRA and LLMs domain-specific insight learning?
Yeah,
It's a mouthful,
it is.
but the core question is really intriguing. Can we teach large language models,
Right.
these LLMs we're always talking about, to go beyond just knowing facts
Right.
and actually understand complex information?
Right. And not just any information, but specifically in specialized fields like medicine or finance. I mean, we've seen LLMs write poems and translate languages.
Yeah.
But can we turn them into powerful tools for deep dives into complex real-world data?
Okay, so our mission today is to figure out if that's even possible.
Right.
And if so,
Yeah.
how do we make it happen?
How do we get there?
This paper dives into 3 types of insights: declarative, statistical, and probabilistic.
And you know what's really cool about this paper?
What's that?
They actually used GPT-4 to help design the experiments. It's like one powerful LLM is helping us understand the learning potential of another.
Talk about AI inception.
Yeah.
Okay, but before we get too deep into the experiments,
Sure.
let's back up a bit. For our listeners who might be new to this, can you give us a quick overview of the paper's approach?
Sure thing. So the researchers used a technique called continual pre-training with LoRA.
Okay.
Think of it as giving an existing LLM a specialized training course on a specific topic.
Okay.
It's like fine-tuning its knowledge base without having to rebuild it from scratch.
So it's kind of like how we as humans take continuing education courses to stay up to date in our fields.
Exactly.
We're not starting from zero, but we're
Yeah.
building on what we already know.
Exactly. And the goal here was to see if this continuing education could help LLMs grasp those deeper insights.
Okay.
The declarative, statistical, and probabilistic that we mentioned earlier.
Okay, let's break this down a bit more. Can you give us some concrete examples from the paper?
Absolutely.
It was something that our listeners can really latch onto.
Let's start with declarative insights.
What?
Imagine you're a doctor preparing for a conference on a specific type of cancer.
Okay.
You need to quickly absorb the latest research on gene mutations linked to that disease.
Right.
A declarative insight would be a straightforward fact like BRCA1 gene mutation increased risk of breast cancer.
Okay, that's a pretty clear-cut fact.
All right.
But you said earlier that even these can be tricky for LLMs.
Right. The challenge is that this information might be buried deep within dense research papers.
Yeah.
It's not like the LLM has a nicely formatted table
Right.
summarizing everything.
Right.
It has to sift through pages of text to extract that one crucial nugget.
So it's like finding a needle in a haystack, except the haystack is a mountain of medical journals.
That's a great way to put it.
Yeah.
Now, moving on to statistical insights.
Okay.
Think about a financial analyst trying to understand market trends.
Right.
They might want to know which companies have the highest debt-to-equity ratios,
Right.
as that could indicate potential risk. A statistical insight would involve the LLM analyzing a bunch of company data and spitting out that list,
Okay.
essentially identifying patterns and trends across multiple data points.
So it's moving beyond individual facts to actually seeing the bigger picture, the
Exactly.
connections between different pieces of information.
Exactly. And then we come to the most challenging type of insight, probabilistic.
Okay.
This is where things get really interesting. Think about a medical LLM that's given a patient's symptoms and medical history. Could it estimate the probability of that patient having a particular condition, taking into account all the uncertainties and complexities of medical diagnosis?
Wow.
That's a very high bar for an LLM to clear.
It's almost like asking the LM to think like a doctor,
Exactly.
weighing different factors and making a judgment call based on incomplete information.
Precisely. Probabilistic insights require a level of reasoning and uncertainty management that we're still trying to figure out how to teach LLMs.
So they gave these LLMs a crash course in specific fields using continual pre-training.
Right.
And then tested them on these different types of insights.
Yes.
What kind of data did they use for this training?
They chose 2 data sets that are really relevant to the real world. Hallmarks of Cancer for medicine and Buster for finance.
Makes sense.
Hallmarks of Cancer is a collection of research papers and studies all about the biological mechanisms of cancer.
Okay.
Buster, on the other hand, dives deep into the world of finance with things like financial reports and market analyses.
Makes sense. They went with domains where those deeper insights are really valuable.
Right.
But these data sets aren't just neatly organized lists of facts, right?
You're right. It's not just bullet points.
Yeah.
They used a really clever approach to make this complex information digestible for the LLMs. They used GPT-4,
Okay.
another LLM, to pull out key pieces of information in the form of triples.
Triples?
Yeah, think of it this way.
Yeah.
Each triple is a simple statement with a subject, a relation, and an object.
Okay.
Like in the hallmarks of cancer dataset, a triple might be BRCA1 gene mutation, increased risk of breast cancer.
So it's like breaking down complex sentences into bite-sized pieces of information that the LLMs can process more easily.
Exactly.
Kind of like giving them a study guide with all the important stuff highlighted.
Exactly.
Okay, so they prep their LLMs with continual pre-training, distilled the data into these handy-dandy triples, and then it was time to see how well they could extract those insights.
Right.
Let's talk about the experiments.
All right, so they had 3 main experimental setups.
Okay.
First, they tested the LLMs without any additional training.
Okay.
This gave them a baseline to compare against.
Makes sense. Got to have a starting point to see if the training actually makes a difference.
Then in the second setup, they applied continual pre-training using LoRA.
Why?
They basically gave the LLMs a crash course in either cancer research or finance, depending on the data set,
Okay.
and then tested their insight extraction abilities.
So did this crash course lead to any significant improvements?
Well, they observed some marginal performance improvements, especially for declarative and statistical insights. However, probabilistic insights still proved to be a major challenge.
So it wasn't a silver bullet.
Right.
They didn't suddenly turn into all-knowing AI oracles.
Not quite, but here's where things get really fascinating. In their third experimental setup, they decided to try something radical.
Okay.
They stripped the documents down to only those essential triples of information.
Oh, wow.
No extraneous details, just those concentrated doses of pure insights.
Whoa, like giving them the ultimate cheat sheet for the exam?
Exactly.
So what happened?
It's quite remarkable. This simplification led to a substantial performance boost, especially for declarative and statistical insights.
Wow.
It seems that by getting rid of all the noise and clutter, the LLMs could really focus on learning those core relationships within the data.
Okay, so not only does the type of insight matter, but the way the information is presented is crucial too.
Yes.
It's like we need to find the optimal learning format for these LLMs.
That's a great way to put it.
Yeah.
It highlights the need for more research on information organization and how we structure data to optimize LLM learning.
That makes a lot of sense, and it's a great segue into our next point.
Okay.
Throughout these experiments you mentioned, they used different sizes of the llama model.
Yes.
Did the size have any impact on the results?
Yes, it did, and this is important.
Okay.
Throughout the experiments, they saw that the larger LLMs consistently performed better than the smaller ones.
Okay.
The 8B model actually showed a 15% improvement in declarative insight extraction compared to the 3B model.
Wow.
It really highlights that the model's capacity to learn is directly related to its size.
So bigger is better, at least in the world of LLMs. I guess more parameters mean more room for knowledge.
It seems that way. The bigger the model, the more capacity it has to absorb information, leading to better performance on these complex tasks.
Okay, so before we move on to novel notions,
Sure.
you mentioned earlier that the research uncovered some interesting variations in performance depending on the type of relationship being analyzed, even within a specific insight category.
Right.
Can you expand on that?
Sure. They noticed that even for, say, declarative insights, the LLMs didn't perform equally well across all types of relationships. Some relationships were easier for them to learn than others, which raises some interesting questions about how LLMs learn and organize knowledge.
Yeah.
It's almost like some relationships are more intuitive to them than others.
That's really interesting. It makes you wonder if they're being influenced by the knowledge they already have.
Right.
Kind of like how our existing beliefs can shape how we interpret new information.
It's definitely something to consider, and it leads us nicely into the novel notions segment, where we can explore some potential research directions inspired by these findings. So we've seen that LLMs can extract certain types of insights, but there are still limitations.
Right.
And you know what's really fascinating to me is this idea of combining this research with advancements in causal inference. What if we could teach LLMs not just to see patterns, but to understand why those patterns exist?
Okay, hold on. Causal inference sounds pretty heavy.
Yeah.
Can you break that down for us?
Think of it like this. Imagine an LLM that's like a detective.
Okay.
It doesn't just observe clues, it figures out how those clues are connected and what caused the crime to happen. That's the power of causal inference.
I see. So instead of just saying company X has a high debt-to-equity ratio, it could tell us why that's happening and what the likely consequences are.
Exactly.
Like moving from observation to explanation.
Exactly. Imagine LLMs that could predict market shifts based on a deep understanding of cause and effect, or identify hidden risk factors in medical data that humans might miss.
Right.
We could be talking about a whole new level of insight extraction.
That sounds incredibly powerful, but also a bit daunting.
Right.
It's like we're giving these LLMs the ability to reason about the world in a way that's been traditionally reserved for humans.
It's definitely a major leap forward and one that requires careful consideration. But the potential is there, and researchers are actively working on combining causal inference with deep learning techniques.
So this is still speculative territory, but the possibilities are mind-blowing.
Yeah.
Okay, before we get too carried away with these futuristic fantasies, let's bring it back to the research at hand.
Okay.
What are the key takeaways from this paper for our listeners, especially those who are working with or interested in LLMs and insight learning?
I think there are three key takeaways that stand out.
Okay.
First, continual pre-training with LoRA, while promising needs more refining before it can truly unlock those deep insights.
Yeah.
We need to explore new techniques and approaches to make this work more effectively.
It's like we've handed them the tools, but we haven't quite figured out the best way to use them yet.
Right. And second, this paper highlights the critical role of information simplification.
Yeah.
Think about it. Those concentrated doses of insights, those triples, were key to improving performance.
Right.
We need to think carefully about how we structure and present data to LLMs to maximize their learning capacity.
It's not just about more data, it's about the right data presented in the right way.
Exactly. And finally, the consistent finding that bigger models perform better underscores the need for continued investment in developing more powerful LLMs.
Yeah.
We're just beginning to tap into the potential of these massive neural networks, and who knows what we'll be able to achieve with even larger models.
I'm already picturing LLMs with trillions of parameters analyzing entire libraries of information in the blink of an eye.
Yeah.
Okay, one last thought before we move on.
Sure.
You mentioned earlier that some relationships were easier for LLMs to learn than others,
Yeah.
even within the same type of insight.
Right.
Why do you think that is?
Well, it suggests that LLMs may not be learning in a purely objective way.
Yeah.
Their existing knowledge base, the data they were initially trained on, could be influencing how they process and interpret new information.
So they're not just blank slates. They're bringing their own biases and preconceptions to the table, just like we humans do.
That's a great point, and it raises important questions about transparency and fairness in AI.
Yeah.
How do we ensure that these LLMs are learning in a way that is unbiased and reflects the complexity of the real world?
It's a crucial consideration, especially as these models become more powerful and influential. Okay, before we dive into some of our own novel notions about the future of this field, let's take a moment to imagine some real-world applications of this research.
Okay.
What if we could truly unlock the power of insight mining LLMs?
The possibilities are endless.
Yeah.
Imagine a world where LLMs can analyze massive data sets of scientific literature and uncover hidden connections between different research areas, potentially leading to breakthroughs in medicine materials, science, or even climate change mitigation.
It's like having an army of super intelligent research assistants working tirelessly to solve humanity's biggest challenges.
And think about the potential in personalized medicine. LLMs could analyze a patient's entire medical history, genetic data, lifestyle factors, and the latest research to develop truly individualized treatment plans.
Wow.
We could be talking about a revolution in healthcare.
Okay, now my mind is officially blown.
Yes.
It's all starting to sound like something straight out of a science fiction novel.
It does, doesn't it?
Yeah.
But that's the beauty of this field.
Yeah.
What seems like science fiction today could very well be reality tomorrow.
All right, well, before we completely lose ourselves in a world of AI-powered utopia, let's transition to our novel notions segment.
Okay.
What are some wild but plausible ideas for future research that this paper sparked for you?
Well, one thing that comes to mind is this. The researchers focused on these atomic units of knowledge, the subject-relation-object triples.
Right.
What if we pushed beyond that?
Okay.
What if we could train LLMs to synthesize insights across multiple interconnected relationships? Instead of just understanding individual facts, they could grasp complex systems and interactions?
Whoa, that's like going from understanding individual words to reading and comprehending entire novels.
Exactly. Imagine an LLM that could analyze a network of relationships, like the interactions between different genes in a biological pathway, or the complex web of factors influencing the global economy.
That's mind-blowing. It would be like having an LLM that could truly grasp the interconnectedness of everything.
It would be a game changer for sure. And it's not entirely outside the realm of possibility.
Okay.
There's been some exciting work on graph neural networks, which are specifically designed to handle this kind of relational data.
Yeah.
Combining those techniques with the insight mining approaches from this paper could open up some incredible new avenues.
Okay, I'm officially on the edge of my seat. It feels like we're on the verge of something truly transformative. But before we get too carried away, let's bring it back down to earth for a moment.
Right.
What are some of the challenges we might face in trying to achieve this level of insight synthesis?
Well, one of the biggest challenges is going to be computational complexity. Analyzing networks of relationships, especially in massive data sets, requires a lot of processing power.
Right.
We'll need even more powerful hardware and more efficient algorithms to make this work.
So those trillion parameter LLMs I was picturing might actually be necessary?
Yeah.
Bigger is better indeed.
It seems that way, but it's not just about size.
Right.
We also need to think carefully about how we represent and structure this complex relational data.
Right.
It's not just about feeding the LLM more data. It's about giving it the right kind of data in the right format.
It's like we need to create a language that LLMs can understand, a language that captures the nuances and complexities of relationships and interactions.
That's a great way to put it.
Yeah.
We need a new kind of knowledge representation that goes beyond simple triples and allows us to model the interconnectedness of the world.
Wow, this is a really exciting area of research.
It is.
It feels like we're at the very beginning of a long and fascinating journey.
It certainly does, and I'm excited to see where it takes us.
All right, well, on that note, we're going to wrap up this deep dive into the world of LLMs and insight learning. We hope you found it as thought-provoking as we did.
Me too.
Be sure to check out the full paper in the show notes and let us know your thoughts and your own novel notions on social media. Until next time, keep exploring, keep learning, and keep those tensors talking.